the channel. So this is Amandeep Singh and I'm back with yet another Leetcode problem, that is binary tree level order traversal. So in this video lecture we're going to be solving this problem, and in this problem we are given a binary tree, the root of a binary tree. We have to return the level order traversal of its node values. So from left to right, level by level, that should be the order. So let's better understand it using an example. So let's take this example. Here we have our tree, and the level order traversal for this tree would be like this. First we'll print 3, then the nodes on the next level, which will be this, that is 9, and then we'll have 20, and then the nodes on the next level, which is 15, and then we'll have 7, right? So that's how we print the level order traversal for a given binary tree, right? So we can see that this is the root node, and the next level, the nodes on the next level will be the nodes which are one edge away from this node. Fine. So how are we going to solve this problem? How we'll be printing this type of order? We have to basically return a set of these vectors or arrays, where each array basically represent the node values at that particular level. So this is level number 1, this is level number 2, this is level number 3. So we have node values at level number 1, node values at level number 2, node values at level number 3, right? Then what we're going to do is we're going to print all of these values. We're going to return the set of these vectors or arrays, right? So let's try to think about how we can solve this problem. Now we can see that we can solve this problem using BFS, because that's what the BFS strategy is. In the BFS strategy, what we do is we basically keep a queue, and in that queue we push the source node of the given tree. So we push 3 into the queue, and then this is the front of the queue and this is the back of the queue, right? Now pop this node from the queue and print it, and push its child nodes into the queue. So push node number 9, push node number 30, right? So print the nodes. Now pop these nodes from the queue, pop all of these nodes from the queue. Why? Because we have to push the entire array into the final set. So push this 9 and 30 into the next set. So push 9, 30 into the next set. Then also push their child nodes into the queue. 9 do not have any child node, while 20 do have child nodes 15 and 17, right? So we'll be pushing these nodes into the queue. Now pop these nodes from the queue and push them into a separate vector, 15, 17, and now push this vector into the queue, right? Finally this vector is my answer, right? And I will be returning this vector from the end of the function, right? So what I did is a simple BFS traversal, started from this source node and simply kept on pushing the nodes into the queue and preparing the final vector, right? So I hope you got the idea how we're going to solve this problem. It's plain BFS. Let's jump to the code implementation part. So here in this code, let's first declare a queue of tree nodes. Let's call it queue u. Into that queue, let's push this root, and let's use the while loop till this queue is not empty, and let's calculate the size of the queue. Let's calculate the size of this queue. Then iterate over the queue, or first declare a vector, also declare a final 2D array here. Let's call it vec, and here into this while loop also declare another vector v. Iterate over the given queue and push queue front, check if this node is a valid node, if it is not null. If it is not null, then simply push its value into the vector. Push back node value. If this node has the left child, then push this left child into the queue. Node left. If this node has a right child, then push the right child of the current node, right? And pop the node from the queue, right? Also, when we have our vector v prepared, which basically contains an entire level of the tree, we'll be pushing that vector into my final answer, which is vec.push back v. Finally, at the okay, this is while loop, so we're gonna be pushing this here, and this q pop is here because we are popping each and every node from that particular level. And here I need to use a check condition. If this v is not empty, if the size of this v is non-zero, then we're gonna push this v into the vec. Then finally at the end of this function we'll be returning this vec, right? So that's pretty much all. Let's try to run this code. Okay, so let's submit it. Okay, so it got accepted. I hope you got the answer. I hope you got the idea how we solve this problem. So this problem was pretty easy. We just had to perform a BFS over the given tree. And I hope you really enjoyed the video. If you like the video, then hit the like button and make sure to subscribe to the channel. And we'll see you soon in my next video. Till then, take care. Bye bye.